Now, types of storage devices and their characteristics. Hard disk. Hard disks are traditionally magnetic storage devices with spinning disks with capacity of up to several terabytes, with the speed moderate or slower read and write compared to SSDs. Generally cheaper by gigabyte compared to SSDs, suitable for bulk storage, desktops and servers. Mechanical durability. Mechanical parts can fail, less durable than SSD. SSDs are quite common in these days. In every laptop, hard drive is removed and SSD is replaced. Storage storage device with no moving parts uses NAND based flash memory to several terabytes, very fast read and write speeds, significantly faster than hard drives. That is the reason in this era SSDs are replaced by HDDs. HDDs are replaced by SSDs. These are more expensive compared to HDDs, ideal for operating systems, applications, and high performance tasks. More durable than HDDs and resistant to physical shocks. USB flash drive. We all know pen drives, portable storage device used flash memory, connects via USB port, ranges from few gigabytes to 100 GB, max I think 256 GB. Varies USB version. There's far the speed is varied by the USB version. 3.4, 3.1, 3.2 was much faster than compared to USB 2.0. Varies by capacity and speed. Generally affordable. Convenient for data transfer and temporary storage. Durable, no moving parts, and resistant to physical shock as SSD. Optical discs or CD and DVD. Discs that are use laser technology to read and write directly. CDs up to 700 MB, DVDs up to 8.5 GB, Blu-ray are up to 50 GB. Slower read and write. Lower read and write speeds compared to HDDs, SSDs. These are low cost, suitable for media distribution, archival storage, and backups. Prone to scratches, Blu-ray more durable than the CD and DVD. Cloud storage. We all know iCloud, Google Cloud, Amazon Cloud. These are online storages provided by third-party providers like Amazon, Google, and Apple. Virtually unlimited based on subscription plans, depends on internet connection speed, subscription based depends on the service. Cost always depends on the service. Remote access and backup services. High reliability. Data is available remotely across any data center. Microprogramming. Microprogramming is a method used to implement the control logic of computers' central processing unit. It involves the use of microprogram, which is a sequence of micro instructions stored in a special memory called control memory or microprogram memory. Each micro instruction specifies the elementary operations that must be performed to execute higher level machine instruction. The command is given here. It is sent to the next address generator, NAG, and then it is sent to control address generator from their control memory to control data register. What is microprogramming's role in architecture? Control unit implementation. The control unit of a CPU orchestrates the execution of instructions by generating control signs that direct other parts of the CPU. This allows the control unit to be implemented as a programmable device. This programmable nature makes it easier to design and modify the control logic. Instruction execution. Each machine distribution corresponds to a sequence of micro instructions. These micro instructions break down complex machine instructions. Simple operation, such as fetching data from memory, performing arithmetic operation, and storing it. Flexibility and ease of modification. Microprogramming allows for user easier updates and modifications to the instruction set architecture, ISA. Since changes can be made by updating the micro core rather than redesigning hardware circuits. How does microprogramming control the execution of instructions? Components involved in microprogramming. Control memory. Micromemory stores the micro instructions that defines how machines instructions are executed. Control address register, control buffer register, micro instruction decoder, sequencer. Execution cycle using microprogramming. Fetching the machine instructions. The control unit fetches the machine instructions from the memory, like here, into the instruction register. Decoding the machine instruction. The instruction decoder the machine instruction and provides a starting address of the corresponding microprogram in control memory. This address is loaded into the control address register, fetching the micro instructions. The micro instructions are the address specified by the CAR or control address register is fetched from control memory and loaded into CBR, that is control buffer register. Executing the micro instruction. The micro instruction is then the CBR is decoded by the micro instruction decoder to generate control signals. These control signals direct the CPU components like ALU, registers, and buses to perform single operations such as data movement, arithmetic operations, or logic operations. Sequencing. Based on the current micro instruction, the sequencer determines the address of the next micro instruction. This address can be a next sequential address and a conditional address based on flags or status bars. An address is specified by a jump or branch micro instruction. And the same from step to 5 are repeated for each micro instruction until the microprogram for the machine instruction is complete. Advantages and disadvantages of microprogramming. I made it into the tables so it is easy to read and understand. Advantages: flexibility allows easy modification of the CPU's instruction set architecture by updating microcode. Simplicity in design simplifies the control unit design by breaking down the complex logical into manageable microinstructions. Ease of emulation facilitate the emulation of different instructions. Granular control provides a fine-grained control over CPU operations, improving sequencing and coordination. Overhead. Coming to the disadvantages, introduces additional memory and processing cycles for fetching and execution, micro-instructions, complexity in implementation, performance impact may introduce performance overhead compared to hardwired control units, especially in high-throughput applications. Requires additional hardware components, control memory, micro-instruction decoders, increasing the implementation cost.